Everybody. So yeah, let's talk about sound cards. So sound cards, they're sound cards for all kinds of computers, but the IBM PC clones kind of where sound cards really flourished. I kind of think about sound cards as like, you've got something, the sound isn't good enough, okay, put a sound card in it. That makes it better. The PC and its clones, they just started off with a beeper, but they had the staying power that kept them relevant through the 90s, kind of into the multimedia revolution. So, you couldn't just use an out-of-the-box computer and have it sound decent. You had to put a sound card in it. And the sound card I want to talk about in particular is the Gravis Ultrasound. But let me tell you a little story about how I fell in love with sound cards in the first place. It was at Babbage's. So Babbage's, went in many stores in malls across the U.S., and they had these monitors in the front of the store. They'd have these looping kind of, demo tapes, and they show games and things going on. And one day I came in, my mom was shopping at the mall, I just went to Babbage's to kill time, and they had Wing Commander playing on these monitors, and there was something I could hear, I could just barely hear it above the din of the store. It was real music coming from a computer game, and I had never heard that before. And I just knew this was something special. This is something I had to experience myself. So I begged and pleaded for a Sound Blaster for Christmas after that. And on the disc that came with the Sound Blaster was a demo for something called Tetra Compositor. You can see it in the lower left there. It's a demo for a tracker program. If you're not familiar with trackers, tracker music is kind of like writing music on a spreadsheet. You've got a roll, you've got different channels, you say what notes you want samples to be triggered at, you can apply effects to them. They started off on the Amiga, they got really popular with Pro Tracker, but they very quickly spread to the PC. And as a result, there was Tetra Compositor, but there was other stuff, Fast Tracker, Screen Tracker, so on and so forth from then on. And I really thought this track music, it sounded so much better than anything else that came on that demo disc for the Sound Blaster. It's like there's something special about this. So I got really into downloading mods off of BBSs and so on. And I started hearing about this sound card that was just made things even better, the Gravis Ultrasound. It was incredibly capable, especially for the price, given that, when it came out in 1992. It had up to a megabyte of sample RAM, up to 32 voices, 16-bit quality. As the years got on, the price got super reasonable, about $120. That was less than the Sound Blaster 16, which technically was less capable than the GUS, Gravis Ultrasound GUS. And it kind of found this really interesting niche because the GUS was a little weird. It didn't do regular streaming audio like the way a Sound Blaster did. It kind of could, but it was a real hack. There were some programming tricks you had to do to set up like these two kind of buffers, and it just didn't work that great in games if a lot of game developers didn't really put in the effort to take full advantage of it. But there were a few things that did really well. Wavetable MIDI, the samples, the patches that it came with were okay. They could have been a little better, but it was super, super well suited to tracker music. And there were a lot of tracker programs that were written specifically for the GUS. In the demo scene itself, a lot of demos needed a GUS. They wouldn't work at all. No GUS, no demo. And that's where I really kind of came into it. And I knew the GUS was very special, so I held on to mine. I never got rid of it. And around 2020, 2021, I found it in a box. I took it out. It wasn't working. I got it working again. And it's something that more and more people are kind of getting interested in. A lot of, the part of this hobby is getting to experience things that you didn't get to experience. And prices for these sound cards on eBay are just absolutely ridiculous. Hundreds of dollars, like these are asking prices, but there are sold prices that are around this range. And as they're skyrocketing, I'm like watching streamers like on Twitch or YouTube, doing these retro streams. Just, I wish I could have a GUS, but I just can't justify it. The price is just too much. So an idea kind of gets into my head that it kind of crystallized in the philosophy behind what I've been doing. Real hardware is great. I love real hardware. I really prefer it myself, actually, if I can get my hands onto a real piece of hardware. But, as these prices climb, why not make this niche retro hardware kind of experience more available and accessible to more people? The real hardware is always going to be there, and full emulators are always going to be there, but like kind of have a middle ground. Like take these emulators into the real world and, like swap out everything but this one little piece. You still have most of the real experience. So as I'm thinking about this, kind of something gets into my head. It's like there are all these emulators out there. There are so many emulators for DOS. I'm pretty sure this list I have here is not exhaustive. Like there's three forks of DOSBox. There's 86box and PCM, and they have most of them have GUS support. You can tell this is something that people are really focusing on and they really want. And it's all open source. There's all these different independent implementations of it. And it's like, okay, this stuff could probably run a Raspberry Pi. Raspberry Pis are fast. They've got the GPIO pins. Maybe I could figure out a way to take that and make some kind of adapter card. I could plug a Raspberry Pi and just put it into an old computer and run this sound code from DOSBox on it. Let's take this, bring it into the real world. And just let's be clear, I have no idea what I'm doing at this point. Like, I am just like, I think this will work. But I lie a little bit. I have some idea what I'm doing. I do software for a living, but I got a degree in computer engineering. And I remember this computer architecture textbooks that we had. It was all about the architecture of the IBM PC. It went really into depth about how a lot of the chips on the original PC worked and how the bus worked. And hey, look, there's a timing diagram of how the bus works. And this must have been something kind of in the back of my head. It's like, you've learned about this before, and just kind of dig it back out, and maybe you can use this again. And I've done some hardware stuff in the past, a little bit of embedded work, not really work, hobby stuff. A friend of mine and I, we worked on this AVR-powered GPS tracker as part of this puzzle-solving event. It would direct you to the next clue. And done some PCB layout as a part of that. But that was like 10 plus years ago. No FPGA experience, so kind of going with what I know. Microcontrollers, PCBs, stuff like that. And this idea of taking a Raspberry Pi and putting it on the ISA bus, it's nothing new. Like Fu and Turing, esteemed hardware software necromancer, posted about this, several years ago. I'm pretty sure I saw these posts, and it's another thing that's kind of in the back of my head. It's like, yeah, this is possible. This is possible. This is something we can do. And also, there's another project called RPI ISA. It was kind of like a one-off experiment that someone else did. Kind of prove it's like, yeah, this kind of thing is possible. So I start learning about ISA. So to give a little bit of background, it started off on IBM PC, and then when it came into the AT, it became 16-bit. And as it got cloned by all these clone makers, they started having their own implementations of it. And it's a mostly agreed upon standard. Pretty much every document that I read about it would disagree on some point with all the other documents. It's something slightly wrong or something's ambiguous. So at some point, I had to get a logic analyzer, plug it in, actually watch what happens when things are happening on the computer. That it's reaching on these I/O ports and starting a DMA transaction, and this is what happens in the sequence. And it's like, oh yeah, this timing diagram is actually lying. Like you have to actually wait a little bit until you do this. You do actually capture the data off the bus in DMA. So, but it does have some good things going for it. It's mostly asynchronous, so the timing doesn't matter too much. There's also this really super useful pin called IO channel ready. You deassert it, you get more time. As long as you deassert it in time, you get more time, which is great. Memory mapped IO is actually pretty easy. It's pretty forgiving on most chipsets. You can really violate a lot of the timing restrictions. So as you're getting started, you can be really lazy. It doesn't mean it's going to work on most systems, but it's kind of that kind of thing where it's like, oh, I got this working. Let's keep pushing at it. Let's keep moving forward and get this thing working. So I went ahead and this is my first KiCad project that I made. I call it the PicoGUS, very dumb name. You Raspberry Pi, you run a GUS on it. It's a very simple board. It uses these level shifters, super basic, hardly does anything. I call it the very dumb prototype because, like I said, I don't know what I'm doing. Let's just go with it. Let's just, these PCBs from these PC manufacturers are so cheap. I'm in for $10. Whatever. Let's just make it work. Let's get something out of this. So here it is, kind of plugged into a PC with the Raspberry Pi hooked on with a ribbon cable because I got a connector backwards. I couldn't plug it directly in. So once I got the first it's like, oh yeah, I'm actually getting data on the bus. Let's get data from the bus. Let's try out AdLib. AdLib, very super common, very kind of one of the first big cards to really make it big on the PC. A lot of titles treated as write only, which is great. You don't have to answer anything back. You just watch for any AdLib-like activity on the bus, and you capture it, and you send it over to the OPL emulator. The RPI ISA project already proved this was possible to do on the Raspberry Pi. And there's a lot of code for it. It's super well documented, so I use DOSBox's OPL2 emulation. And to get it to run on the Raspberry Pi with good timing, there's this bare metal library called Circle. The MT32 Pi project is based off of it. If you're familiar with that, it's great. And so 12 days after I got my board, I finally got actual OPL2 playback going on the Raspberry Pi. This was crazy. I did not expect this to work at all. It was like super encouraging to me because it kept me going. I expected this to be like a one-off dumb experiment, but it actually freaking worked. So I was like, okay, yeah, this is awesome. My dumb little card actually does its job. It's actually fast enough on the Raspberry Pi. Let's do GUS. Let's just do it, and it's just like let's just keep on going. Every step is, what else can I do? Again, I'm going to cheat to kind of get some early success. I can take advantage of the fact that a lot of titles don't use interrupts. They just use the PC's timer. They don't use DMA to send samples to the card. They just poke them in via I/O at a byte at a time. And again, leaning on like DOSBox. The DOSBox staging has a GUS emulation core. It's super clean, very nice. It was easy for me to understand as a noob to a lot of this stuff. I switched to polling on ISA instead of interrupts because I just couldn't get the timing perfect with interrupts. I was talking online with Claude Schwartz, who did the PyStorm project for the Amiga. He's like, yeah, I just do this stuff. I just use polling, and it works great for me. So that's what I did, and actually it really helped my timing. So yeah, a week and a half later, I actually got it working on GUS on the Raspberry Pi. This is Starshine by Purple Motion. He is a Finnish demo scener from the early 90s. I love all his music, and this was kind of one of my favorite tracker songs. So, hearing this for the first time and like it not sounding like crap was just like it was so satisfying. So just let this play for a little bit. And that's like the logic analyzer program. You can see kind of in time with the music the different events coming across that are from the GUS. So all of this is possible without supporting a lot of the stuff that GUS supports because it's about getting that kind of early win to kind of keep myself invested and kind of want to work off and build off of it and go to the next step. So yeah, I was feeling awesome, like not just pretty good, like freaking amazing. But there was something kind of eating at me in the back of my head. This was 2022. It was the height of the chip shortage still. Raspberry Pis were very hard to find. Like there's a screenshot of this RPi locator. It was a site would like send you a notification if like some shop would come in stock. You'd rush and grab it. People were scalping them on eBay for like $100 for a Raspberry Pi. I mean, that's crazy. But then again, Raspberry Pi selling Raspberry Pis for $100 now. Beside the point. But this was not solving the problem where it's like I want to make this experience more accessible to people. If they're not going to be able to find a Raspberry Pi, like they're still going to be locked out. So, I was keeping this in the back of my head, and I went ahead and I posted a thread to Vogons. It's a, super, popular forum. A lot of people talk about DOS on it. Originally stood for very old games on new systems, but now it's most people on it talk about old games on old systems. And I posted a thread about this project. It's like, hey, look what I've got going so far. It's kind of cool. What do y'all think about it? And on the very first page of replies, there was this one, which just blew everything out of the water. It opened up so many things in my head. It's by this user RasPL. I assumed you would need the Pico RP2040 with PIO to respond fast enough. Add a $2 8 megabytes by PS RAM, and you could do any sound card emulation on the Pico. I was just thinking, maybe that's possible. Because like when I was thinking about the Pico, it's like, yeah, it's just a little microcontroller. It's like, that's for blinking LEDs, right? It has 384K of SRAM, which actually is a lot for a microcontroller, but it's still not enough to hold all of the samples that the GUS uses. But when you mentioned this SPI SRAM, PSRAM, that has 8 megabytes. That's plenty. And if it's fast enough for playback, yeah, this could do the job. So again, it's this kind of thing. It's like, okay, let's just try it. Let's just see what happens. And the thing that made me think that it probably is possible is this thing called PIO, which is a feature on the RP2040 microcontroller on the Pico. It's a secret weapon, and it's the reason why so many projects for old computers use the Pico. It's just super well suited for it. You program with this assembly-like language. Each instruction is just one cycle. It's very predictable. The timing is perfect. And it can tie into the RP2040's DMA engine. So without any CPU involvement, you can just pull in data from the bus. And you can get interrupted or you can pull for it. It's super flexible. It's really awesome. So I went ahead and I kind of took my existing board, instead of having a Raspberry Pi plugged into the back of it, this mess of DuPont wires going to these breakout boards with muxes on them and going into the Pico with this little DAC board, because the Pico doesn't have any audio output on its own. And I was like, okay, all right, I'm getting some bus events. I can read and write data from the bus a byte at a time. Okay, let's go. Let's do AdLib again. AdLib was easy, right? On the Pico, it's not. The OPL emulation libraries, it's more than a full core. The PicoGUS 2 cores are used, just to emulate the OPL. Like it seemed like a non-starter. But my savior, Graham Sanderson, who works for Raspberry Pi, he's an optimization genius. He actually got full Doom running on the Pico, and as a part of it, he had to just emulate, he had to optimize just the hell out of this OPL2 library, and he actually got it working for like a quarter of a core, even less than that. Like stuff like that makes it possible. Like again, there's another story. It's like the open source community that made this possible. Like if I had to do this all by myself, it would have been possible. Just building off of stuff like this. So like a little more than a month afterwards, I get OPL2 running on the Pico. Again, on my mess of wires and stuff, I was amazed that the ISA bus was okay to run over random DuPont cables all over the table. And that's Jar Jar Binks in the background. I've got this wall hanging. So it's like at this point, it's like, okay, all right, let's just go. Let's build a card. So like I scrambled, like within a week, I designed a PCB, again, thanks to these PCB manufacturers that you can just get quick turn stuff from. And PicoGUS is born. This PiGUS has become PicoGUS. And this is the first version. It's definitely not perfect, but it's good enough for me to start and do the next thing, actually get GUS working. It's like, I kind of did the math a little bit. It's like, I think this is possible, but I'm not really sure. I'd overclocked the RP2040 by more than 2x, but it's super overclockable, which is awesome. Using DOSBox X's GUS emulation as a base. There's no FPU on the Pico, so it's all fixed point. It's very well optimized. Another cool thing about DOSBox X is they focus on compatibility with demos, which is what I really care about. And again, incremental approach. Let's start with chiptunes, which means very tiny little samples. They're small enough to fit just in the SRAM on the RP2040. Then I'm going to need to work on getting PSRAM working. Then after that, I can worry about interrupts. After that, I can worry about DMA. That turned out to be the biggest challenge ever, harkening back to the fact that all those timing diagrams lie. So 13 days later, I got the start of GUS going on the PicoGUS card. It's a very, very well-known chiptune. It's in a lot of key generators, if anyone was a filthy pirate back in the days. And you can see here, it's not very well optimized at a certain point, because once more and more channels get in, the audio starts breaking up because I start running out of enough CPU cycles to keep up with it. Like right there. So but still, it's like, yeah, I got some working, this is working, like this is something I can build off of. So after a lot of bodges, like I said, I rushed to get this board done. Bodges all over the place. I had to make this whole other reset circuit kind of off to the side there. I got the pin ordering wrong on my DAC. I wound up with what I kind of consider the final 1.1 board. And this board is still supported by the PicoGUS firmware today. It does everything, almost everything you'd ever want out of a PicoGUS. It also has MIDI output, which is something I really care about. So yeah, over the next year, after all that super amazing kind of initial kind of progress, it's like, okay, let's start iterating. Let's fix all these edge cases. Adding IRQ and DMA support to the GUS, adding new modes, because like, hey, you can emulate GUS, you can emulate just about anything else. So Tandy 3-voice, which, if you don't have a Tandy 1000, a lot of people won't be able to kind of experience unless they're running in a full emulator. CMS, Game Blaster support, both of those were contributed by Aaron Giles, like super well storied emulator author throughout the years. MIDI support, again, super important to me. I added intelligent mode, MPU 401 support. Roland, I love MIDI. So a lot of people just buy the PicoGUS just for the MIDI support. Like, they don't care about anything else. It's still cheaper than anything else out there if they want intelligent mode, MPU 401. So yeah, this project's getting more and more attention. It's starting to get contributions from the open source community. It's like, yeah, people are looking into this. It's like, hey, this is cool. Like, can it do this? Or like, hey, this is broken. People saying like it doesn't work on the system. Like, I want to hear that. Like, please tell me if something's broken so I can actually have a chance of fixing it. So, I'm feeling really good about this. So it's like, I'd say I'm going to go to VCF Midwest 2023, get a table, show stuff off. It's like, yeah, it's just like, hey, I sold a few cards kind of, here and there. But that wasn't really a big focus. But I call it fateful because I meet somebody there. He walks up to my table, this guy, Adrian Black, who a lot of you know about. He's like, hey, this is really cool. Can I have one of these? And I said, actually, I'm out. I'll let you know if I have any more. And he bought one from me. It's not like I had to give one to him to get him to cover. He's like, no, I love this. I want to cover this on my channel. And he did. So this felt like the tipping point. It was like, this is going from more than just a bunch of DIYers making these together. People are just going to buy this to use it, which that's awesome. So okay, I got to figure out a way to make these things available for sale. So I put up a page on Tindy. People could start pre-ordering, not pre-ordering, giving interest. So I was like, okay, I need to make a lot of these things. Because I could see the pre-ordering ticking up and up and up and up. It's like, I'm going to make hundreds of these things. So it was more than a DIY project. People just want to buy cards. And so I wanted to make something for that kind of person. So it kind of is the current version of the card, PicoGUS 2.0. It was designed in a hurry. I keep on designing things in a hurry. Fortunately, I didn't make too many errors in this one. And adds new features like a wavetable header, because all these cards you can add a wavetable module onto them. And also USB-A port, because the Pico supports USB. You can plug a modern Xbox controller into it, and you can play old DOS games on it. It's kind of as my kids say, OP, playing these old games with a modern game controller is actually makes some of them make them way too easy. But a big thing is I wanted something I could be 100% assembled by JLC PCB, which was the PCB maker I was making. No little modules like the DAC module, the Pico itself. That's a module. Because hand assembly sucks. I hate soldering the same thing over and over and over and over again. So another thing I wanted to do, cost optimization. I want to be relentless about this. I want to keep this thing affordable. I want to make sure this is accessible to as many people as I can. So, sourcing chips from alternate suppliers than Shenzhen. Alibaba is awesome. I figured out, if I just have this digital wavetable volume control chip, that's cheaper than a little potentiometer that I put on the board. Stuff like that. And it's actually a little bit neater to do because you can put in your little batch file to set the volume. Another thing that I wanted to do was have metal brackets, a real sound card. And I found a supplier in China that could make it close in cost to getting a 3D printed one. And it was a lot of back and forth and me learning CAD and all this stuff to get get this done. But like at the end, it was something that a lot of people liked. So like it snowballed. Like people were doing videos about it on YouTube all the time. It was just crazy. It just, as soon as someone would find out about it, like they tell other people about it, and people would post about it online. And like this Russian like guy did a video about it, and I have no idea what he's talking about it, but like GUS, GUS. So yeah, it was just becoming just this huge thing. Brendan, who is also here at VCF, he's giving a couple talks about chiptunes tomorrow. Please check him out. He put me in contact with someone at Make Magazine. They were doing a retro tech issue, and I figured that was something that would be really cool. So I wrote an article for Make Magazine, which is like I read Make for years, and that's a big dream of mine, which was pretty awesome because I never thought it's like, oh, I'm a maker, I guess. So this chart here is like the number of pre-orders like over several months, and like every inflection point is like someone does a video about it, and the pre-orders go up like crazy, and it's getting into the thousands here. I want to get out of making it myself. Like I was having my whole family like assembly line style like testing these boards. Yeah, child labor. Like my father-in-law was like putting boxes together, and like my kid was like screwing the brackets on, and like it was this whole thing. I was like, okay, this was fun for a bit. Like I want to get out of this. Like I want to work on making the card better, not like putting stuff into boxes. But fortunately, like people start like out in the kind of the hardware kind of selling community approached me as like, hey, I could sell these for you. So like JCM1 here in the US, Certishop, who's an awesome store in the EU, like they focus super big on MIDI stuff, which is really cool. Like they make special editions of the little Dream Blaster cards for the PicoGUS, which is really fun. Philly Millie in the UK, and also it's open source. Like so, people have just like it's like, hey, I want to make a batch of these for like a local user group. It's like, yeah, that's awesome. And like that's a big thing. It's open source from the start. Like it was developed out in the open. I was just committing stuff to Git like as I was working on it, like whether it worked or not. Like I had hardware designs that were broken and people made PCBs out of it, and I was like, I'm sorry, it doesn't work right now. You just happened to pull the repo when I was like in the middle of fixing this one thing. But like that's enabled so many contributions from the community. People like who understand the PC way better than me. Like adding USB mouse support was from the community. Sound Blaster and NE2000 support from Kevin Moonlight, who's been instrumental in a lot of other retro hardware projects. Multi-firmware support, so you could just switch the modes like instantaneously. Like this one person's like, hey, I'm gonna get your firmware building in GitHub Actions. I'm like, cool, that's awesome. In documentation improvements, because I'm bad at updating my documentation, and just bug fixes, like, hey, Sound Blaster mode doesn't work in Windows 95, here's a patch that makes it work. It's just really amazing to have this kind of, from the community, seeing things kind of become more than just me, which is really awesome. And that also enabled variants. People have taken the PicoGUS and done their own thing on top of it. I'm going to start with a variant I did myself. A few years ago, this little hand 386 came out, and later they came out with a pocket 386. It has a little ISA busted pin header on the side, so I made a little thing that could plug into it, the really kind of miniaturized version. People keep asking me to make more of these. I really don't like making them because that connector is a real pain to solder. But like people made PC 104 versions of the card, so they could use them on these single board industrial PCs, which is really fun. That one on the right there, like they integrated MIDI synth onto it, and like I could tell like their analog section is probably better than mine. So it's really cool like to see like these kind of things coming up over and over again. Someone added SPDIF digital output onto it, so like it like my I don't know, MIDI UART or whatever. It's like, oh yeah, you can just use it's a Pico. You can just output whatever on any pin. It's like I'm going to have it go to the SPDIF port instead. Like this person in New Zealand wanted to make stuff for the local kind of New Zealand retro scene, and like kind of made the Kiwi version of the PicoGUS with some extra artwork on it. It's like that. It's just really awesome to see kind of people take this like I could see some people saying it's like, oh, it's getting out of your hands, but I'm thinking it's like, no, this is amazing. Like I kind of put this out here and I'm doing my own thing, but people can do this, and like it's this big kind of community that's growing. Ivan Bowler, who did the Llama ITX and the Tiny Llama, which are kind of miniaturized PCs built on the 86 Duino platform. The Tiny Llama 3 is going to have a PicoGUS integrated onto it on this little module. And like that's why I'm working to make sure like Windows Sound System support works, or Sound Blaster 16, so you can also use it really well in Windows games. And also this uses the RP2350, the next generation chip from Raspberry Pi, so it's going to be capable of even more. So it's just really amazing, like seeing like what people have just taken with this and run with it. There've been unexpected platforms. It's really hard to see because it's dark. That's a PicoGUS and an Atari ST. Like someone like made this homebrew version of the Atari ST with ISA slots on it, and they have a PicoGUS running in it. They ported my init program to the ST. I don't know. It's crazy. There's also been a few other projects done by other people that were kind of inspired or kicked off by PicoGUS. The Pico Mem, which is another probably more capable than the PicoGUS card. Freddie V approached me pretty early on in the development of PicoGUS and said, this is something I wanted to do for a long time, and you just proved that this was possible. So he's added on a lot of stuff. He wrote his own custom BIOS for it, so when it starts up, you can have the Pico Mem emulate floppy and hard drives, emulate EMS memory. It takes in some stuff from the PicoGUS, like sound support for stuff like AdLib, USB joystick support, Wi-Fi support. It's an amazing project as well. Another thing is that I talked a little bit about that Pocket 3D6 computer. Another developer came up with something called the Pico Pocket. It takes the idea of the PicoGUS but expands it out again. It's its own thing, but he's also kind of ported the PicoGUS firmware back to it. So inside this tiny little kind of newly made 386 kind of palm top PC, you can add actual real good sound onto it or add Wi-Fi onto it, and it's internal to the machine. It doesn't stick out the side like the card I made did. So like as I think about this, what's next? Like here's where we are today. So Windows Sound System support, Sound Blaster 16 support, CD-ROM emulation. If we can work to get the USB port on it working fast enough, you can put a little USB stick in with ISO files onto it and emulate a CD-ROM with it. It's more than capable of it. That's like Kevin Moonlight, YYZ Kevin, he proved this was possible. So like that's with the current hardware. Like, okay, what if I move to this new chip from Raspberry Pi? It adds more IOs onto it, so you do audio capture, multiple analog inputs, like kind of become more like a real sound card, because this card, it's like it outputs only. OPL2, it's kind of my white whale, because like that's the chip that's on the Sound Blaster Pro, Sound Blaster 16. So many other cards use the OPL3, and like I'm not good enough at optimization like Graham Sanderson was to make it run on the Pico. It's like, well, this is probably going to make it be possible. So, yeah, as I'm thinking about this, like I want to thank you. I want to thank everyone in the community, because like it's more than just me, because I built off of open source software to start. I took these emulators that already existed from the start. I'm taking contributions from the community in, and it's become more than just some person like me in the basement just tinkering away. It's like it's come out into the world, which is pretty awesome to see. So yeah, with that, I want to thank everybody. And this is where you can find me. Any questions?
I don't know much about the difference between original XT 8-bit ISA and 16, but many of these cards were like 16-bit, and you have only an 8-bit. So can you, like, is there any compatibility issues or?
Yeah, surprisingly, no. Like 16-bit, 44.1 kilohertz audio, it's actually plenty for an 8-bit slot. It has enough bandwidth for it. And also, the really cool thing about when you do a 16-bit I/O on the PC, if the card doesn't assert this one signal saying it's a 16-bit card, the chipset will automatically split it up into 2 different 8-bit transactions for you. So there's a lot of stuff that assumes is going to run on a 16-bit card that actually can run on an 8-bit card. And due to the fact of the limited number of IOs on the Pico, 16 isn't really possible. So like 8-bit's kind of a necessity. So like I was thinking like that probably should have put on the slide. Like that, like a true 16-bit card might be possible with the added IOs on the new RP2350. But it's amazing like what you can do over just regular 8-bit.
Thank you.
Yeah. I have the same one. Oh.
Yes, speaking of features and all that, I'm trying to like rebuild one of my computers. I really want CD audio in so I can have my CD-ROM drive or optical drive talk to my audio card. Was this like a feature ever discussed in the community? Because I don't know much about PicoGUS outside of the general zeitgeist.
Yeah, as it is today, you could kind of hack the wavetable header as an analog audio input for your CD-ROM drive, but it's not like officially supported. And like that's what I want to do with the next generation is like the actual little thing you just plug in either your analog or your digital audio from your CD-ROM drive, because that's something I did a lot back in the day, and I want to be able to do that on PicoGUS as well.
I'm just waiting for that feature too, because I don't want to sacrifice a good wavetable port, especially if I have extra wavetables.
Oh yeah, if you've got wavetable cards, use them.
Yes.
This is an amazing project, and it's clearly been fulfilling for you. You can see it in your how excited you are about it and all that. But like, do you ever take time to think about like how much time and money you actually invested to get to here, or is that just like start this like tailspin of introspection of like why am I even here?
Yeah.
Oh, I was wondering about that. I was like, and are you still married? But that's pretty rude.
Yeah, she had no idea what I was doing down in that basement, by the way. If I had to put it in, if I had to pay myself to do this, this would not be profitable at all. And the initial cost to me, like I had to put money in to like get those first batches made, but after that, like the snowball was already rolling, so I didn't actually have a lot of money into it, but a lot of time. It was crazy.
Hi. So
Hey, Steve.
you learned a lot, obviously, with this project and bashing kits together and doing a lot of fun stuff. Is there any other things that you're working on, like not related to sound cards, that are of interest to you?
I a little while ago, for some reason, I got really interested in the Apple ImageWriter 2 printer. And the fact that you need this special add-on card to put it onto a local talk network. First time I saw one of these cards, like that's a bunch of Jelly Bean parts and 65 CO2 and this serial I/O chip. Like I could clone that. So that was something I got into last month was March, hence Marchintosh. So I made that available in time for Marchintosh, and a bunch of people got these cards and they put their ImageWriter 2s online for the very first time with this card I made. So it's completely out of the sound thing. It's just like, that's really kind of funny, and like, I thought printers weren't cool when I was a kid, but now I think printers are cool, or at least old dot matrix printers. So yeah, stuff like that. I've made other things like for like small little doodads for like my Amiga to like make sure I could have like, it could mux the hard drive LEDs, like if I had 2 hard drives into it. Just weird stuff like that. There's all kinds of things kind of coming into my head, but like PicoGUS is kind of my main jam still to this day.
Anyone else?
Do you have any advice for someone who's trying to route their own like ISA-ish card, like where I should even start with? Because I get overwhelmed by looking at a keycap.
Yeah. I think I alluded to it in a few places, is like you don't have, if you interface with the ISA bus, you don't have to implement the whole thing. There's like, you just need a few signals. Like if you are only caring about reading writes on the bus, there's like IOW, which is one signal, a few of the address pins, all 8 of the data pins, and if you need more time, the IO channel ready pin. And like once you kind of figure that out and you say this goes high, read the address, do
So like
something with
the
it.
schematic part, I'm good with. I actually
Yeah.
got the schematic together because it's very simple. What I'm trying to do, it's the routing the card.
Oh, yeah. When I was initially, like when I showed that one project I worked on like many years ago, that was auto-routed in Eagle or something like that. I never thought I could actually route the cards, but when I used KiCad, it doesn't have an auto-router. I think there might be one you can add on to, you can use now. And I kept on hearing people saying, oh, just do the routing. It's actually, once you kind of get over the initial hump, it's actually I find it soothing. Like, I'll just like sit down and
Like-
route a PCB.
Like I've heard
Yeah.
like the rule of like go vertical. I forget.
Yeah,
what
like
it is.
Manhattan
go vertical on
routing.
one side, horizontal on the
Yeah.
other side. That way you don't have to play the
Yep.
spaghetti game and
Yeah,
so
that's
and stuff
exactly
like that. And but it's like, but KiCad, just like even trying to get the place the parts, it feels like I'm just like, what am I doing here? What?
Yeah. Yeah, I mean, for me, it was like, I didn't know what I was doing. I just went for it. And like, I had errors in my first cards, but
I might
like,
just have to sit and
yeah. Yeah, like what you talked about that routing, like I was kept on running into like spaghetti and all going all over the board until I read about that. It's like, oh, yeah, actually that makes a lot more sense. And then actually I was able to route everything.
Anyone else? Okay, thank you very much.